Thanks a lot for the invitation. I'm happy to be here. So I'm going to talk about technical debt. And first of all, the question is, why am I even giving this talk? So in my opinion, handling technical debt is quite important to handle, to be successful in software development. And that is why I think it's an important topic. And actually, there are quite a few misunderstandings that I'm going to talk about in my talk. And I want to allow you to make decisions about technical debt. So it's actually, well, it's sort of a philosophical talk, but there is some practice to it. So it is supposed to tell you how you can actually handle technical debt. So first of all, let me tell you why technical debt even matters and what it is. If you look at some piece of software, there is the external quality, and the external quality is what users see. So it's about performance, availability. So I can tell whether an application is fast or slow. I can tell whether an application is up or down. And obviously, this is very important for architecture. You can have quality scenarios to pin that quality down and to make sure that you actually achieve the quality that you need to achieve. However, there is also the internal quality, and that is what developers see. So it's about code quality, it's about code structure, it's about tests. And it might be related to external quality. So if the code quality is low, chances are that also availability and so on might not be that good, or performance might not be that good. But at the end of the day, it's something different. So you have to look at the code. You have to develop the software to understand what is going on. And technical debt is solving a problem that you have with internal quality, because not just developers need to think about internal quality, it's also important for managers. So if you have less progress in your project, maybe that's because you have high technical debt and low internal quality, and you have to think about that. And it's hard for you to understand that if you don't really code. So that is where that metaphor comes in. So technical debt is a metaphor to explain internal quality and to make it possible to, well, make decisions about it. And if you look at the definition at Wikipedia, it says that technical debt is the cost of additional rework that is caused by choosing an easy, limited solution now instead of using a better approach that would take longer. So basically, the idea is that I take some shortcut now, and that shortcut is something that will be hard later on, and that will, well, is a limited solution for the time being, and I will have to rework it afterwards. This definition basically says it's a conscious decision. So someone actually made that decision, and it is, well, a decision. So therefore, debt can be avoided. So there has to be something like a debt-free system. That's basically what this definition says. It even seems to imply that such a thing is not that hard to achieve, right? You would just take the better approach all the time. And the reason why there is this why it's debt that they're using as a metaphor is because, as with monetary debt, if you don't repay the technical debt, then it accumulates interest. So it becomes more and more and more. And therefore, it becomes even harder to implement any changes, which again implies that it can be fully repaid. So there is something like a debt-free system that you can have. So the way that I think about it is, well, technical debt will increase over time if you don't take any countermeasures, and therefore productivity will decrease. So that's basically what this metaphor seems to say. However, if you look at it, actually the true story about technical debt is quite different. And therefore, I want to talk about the origins of the metaphor. And I think this is important to understand what this was really supposed to mean at one point. So the origins of the metaphor can be traced back to Ward Cunningham. So that's him. And he is famous, among other things, for being the inventor of the wiki. And he worked on a project called Ycache, and therefore he chose that specific metaphor because it's a metaphor for financial experts. So financial Ycache is obviously an application that is somehow concerned with money, and debt is something that experts on these kinds of applications should understand. And what Cunningham actually meant, and this is something that he wrote down and he also did a video about it, is that teams learn new facts about the domain, and those facts should somehow be represented properly. So they should be represented in a way that the system represents them as good as possible. So sort of like domain-driven design. So therefore you have to refactor your system. So you learn something new about the domain. Oh, really, this is how it works. So the last example that I heard about is flight numbers, and flight numbers seem to have some kind of special code in them that says actually something about the flight. And the team only understood that later in the project, so they had to refactor the system to represent that knowledge. And if you don't do that, then what Cunningham says is that you are in debt. And here are the sources. So the original wiki actually talks about what Cunningham and his idea about technical debt. And there's a YouTube video, I took a screenshot from it, where you can listen to him, and he explains what he actually meant with that. So this is somewhat different, right? So technical debt is a lack of understanding. And it's not a lack of understanding because I'm just stupid. It's because we are learning while we are developing software. And therefore, it's not a conscious decision. It's something that just happens. I can't avoid it. It's an ongoing learning process. So I can't avoid that I missed that idea about the flight numbers, and I will learn it later on. And also what he says is that technical debt should be repaid immediately. He doesn't actually say that you should postpone that. Quite the contrary, he says you should do that right away. And that's very different from the original definition. And I think that's quite interesting because it means that, well, there is something going on here, and at least the definition on Wikipedia that we probably all agree is like the real definition of technical debt. Well, maybe it's not really the definition after all. There is another attempt to sort of defining what technical debt actually is. And that is something that is an approach that Martin Fowler took. He is quite famous for, well, being one of the persons who did a lot of stuff in software development. So he wrote a PhD thesis, I think, about refactoring. He is working for ThoughtWorks. He's publishing lots of books, and he's really one of the knowledgeable persons in software development. And he talks about technical debt quadrants. So he says there is either reckless or prudent technical debt, and it's either deliberate or inadvertent. And there is a citation here for each of these quadrants. And deliberate and reckless is we don't have time for design. So we are reckless. We don't really care about design. We could do design. It's a deliberate decision that we don't do design right away, but we don't really have time. And the inadvertent reckless version is what's layering. So you don't even have an idea about architecture, about the fundamentals of architecture. So you end up with a system that has technical debt, and it's not a deliberate decision. It's rather that you will come up with a system that is suboptimal just because you don't really understand what's going on and how our software development works. And then there is prudent. And prudent, deliberate is we must ship now and deal with the consequences later, which is a sensible decision, right? It basically says that we have to have that out right away for some business reason, and later on we will fix it. And inadvertent and prudent is, well, we were just stupid, and now we know how it has to be done. By definition, this says that you end up with technical debt even if you don't take a conscious decision. Actually, it doesn't really talk that much about conscious decisions at all concerning technical debt. It rather says that you are either reckless or prudent. And that doesn't probably say that there will be a meeting where you say, okay, this is something that we decide in this way or another. It's rather that you go for, well, recklessness. in which case you won't have those meetings anyway, and you just develop software as fast as possible, and you don't do individual decisions where you say, okay, we're going to take technical debt right here and right there. It's just that overall you're aiming for high speed for the time being, and you don't really care about the consequences later on. And with inadvertent, that also says that it's something that you cannot really avoid in those cases, right? It basically says that it just sort of happens. So those quadrants say that if you're inadvertent, technical debt just happens without you taking any decisions at all. And Martin Fowler doesn't really talk so much about repaying. I mean, repaying is in the center of the definition that we saw at Wikipedia, and also the definition that Ward Cunningham said, but it doesn't really seem to be that important for Martin Fowler. And the question that I have, or that I'm wondering about, is recklessness actually the number one reason for debt? So it's probably not a decision where we are saying, okay, this is a decision where we take that not so good approach. This is another decision where we take that not so good approach, but it rather is that the project will, well, work recklessness, and then you will end up with lots of technical debt. Avoiding technical debt is only possible if the debt is deliberate. Otherwise, you can't deal with it anyway. So that is the decision about ship now, deal with consequences later, which actually might make sense. However, something like not doing any design, well, is stupid, and probably it's obviously stupid. So it's not like, I mean, you don't need a consultant to point out that not doing any design whatsoever is not such a brilliant idea. So it is a conscious decision, but it's not a decision where you think a lot and you reflect and you come up with a trade-off. It's rather that you say, okay, we are not going to do that, and it's plainly stupid. If you just tell it someone who has some idea about software development, they will come up with the point that it's not really that good an idea. So avoiding technical debt, well, sometimes debt is okay, because if you have to hit the deadline, and if you don't, then your company will go belly up. Then you have to hit that deadline, and that's it. You should probably avoid recklessness, which basically means that you should think about what you're doing, but that's quite different from individual decisions. It's more like the culture that you have and the overall approach that you take. And I'm not sure whether any technical approach will help here. A tool that points out to you that you do have technical debt won't help you if you're reckless, because it will just tell you that something is wrong, but you will probably go on and do that. So therefore, the question is whether technical debt is sort of a cultural problem. And let me say that the decision for technical debt is a valid one. The example that I usually take is, let's imagine that I started some kind of startup, and I have enough money to run that startup for a year. So to pay that development team for a year. So after a year, I have a system that is debt-free, but I don't have any users. Then we can just close down the company, because I can't afford to progress anymore, because I don't have any money anymore. And I also won't get any money from any investor because, well, there are no users. So obviously there is no market. If I have a system instead that has high technical debt, and I actually have an easy to use system, a system that users love, and I have therefore quite a few users, then that's much better. So taking an approach for that year that actually accumulates lots of technical debt might be a sensible decision. However, of course, developers won't love working at the company because, well, it's going to be a mess after a year. So what's the problem with technical debt? I would, first of all, say that technical debt sort of just happens. It's often no conscious decision. It's not a decision that I make, that I take a compromise here and a compromise there. And in some cases, it's just something that happens. So let's imagine there is a new version of that framework that we're using all the time. And now there is a simpler way to do something. All of the code that I wrote before that uses the hard old way is sort of technical debt now. It's not as it should be. So all of a sudden you have lots of technical debt in your code, and that's obviously not a conscious decision. It's something that just happened. Someone released in your framework. There is a new, easier way to do things. Or a developer leaves the company and now nobody understands the code. That is all technical debt now. It's hard to change code, but it's not a decision that I made. It's rather something that happened. And that developer could also become sick or whatever. So in that case, again, it's not a decision that I make, it's just something that happens. So if technical debt is not caused by conscious decisions, how can it even help to make conscious decisions? I think this is very important because at the end of the day, it's about what do we do in the projects? How can we come to a situation where there's technical debt, where it's more productive to develop in these kinds of things. And if technical debt is not the result of any conscious decisions, then it doesn't really help me to make those decisions. But that's basically what is, at least for me as a consultant, very important. How do I come up with good decisions? And I have actually created a screenshot of an old version of Sona here because I found that quite interesting. And that version actually says there is technical debt in this code base. It's an old version of Spring Security. Spring is actually well known for its high code quality. And it says that there is a debt of 78 days in there. What does that even mean? So can I send a developer out and say and tell them that they should fix the system and it'll take 7-8 days? How is that even relevant? Should I really now get a developer and make that person do that? And is there even such a thing as a debt-free system? I think oftentimes we can have interesting discussions about how something should be done. So there is no obvious single best way to do it. And the final question is, so why would I even reduce the debt? Spring Security, all the Spring frameworks are known for their high quality. Why would I reduce the debt? It seems to be quite fine. It is, if you listen to people, they say that the code quality of Spring Security is very high. So why would I even improve it further? I would actually argue that there is no system that couldn't be optimized. And usually there is no lack of possibilities to optimize the system. It's rather, what do you want to fix first? So therefore, a complete inventory of technical debt that says these are the things that we could make in better doesn't really help me at all, because it's easy to figure out what can be done better. Usually, you can just talk to a developer, to some person involved in the project, and they will come up with lots and lots of ideas that they can fix. And as I said, I have yet to see a project where developers would say, well, the code base is perfect, no need to improve anything. So it doesn't really help me to understand that there is a lack of quality in parts of the system. It's rather that I should focus on what I want to improve. There is no lack of opportunity for improvement. It's rather a question of focus and what I should do. Also, I would say that technical debt is actually meaningless, because technical debt says that changing code is hard, but if the code is never changed, then I don't care. So code that is never changed, that is never needed to be changed, technical debt is something that I don't care. So coming back to those 78 days, if that technical debt is in a part of the system that you will hardly ever change, then that number is just completely irrelevant. And showing it to someone, and in particular to some manager, will do more harm than good. Diagrams and code might be ugly. That is a reality. So most of the system that we work with, there are at least parts that are, well, ugly. But I would argue that architecture should be led by business decisions and not by aesthetics. So what I'm trying to say is, if there is some part of the system that is really, really ugly, probably we as technicians are annoyed and we want to fix it. But I would argue we shouldn't fix it unless there is a good business reason for doing so. And if you want to have a system that is pleasant to look at, you should probably look somewhere else, not in the business world. And I think that's something that is very important. However, there is this one point. So if technical debt increases, at one point the productivity might just hit zero, and that is probably what we are afraid of. And this is also something that why it's hard to deal with this whole thing, because it's not like, okay, we are going to increase technical debt and it's going to be fine, but at one point, well, you're basically facing bankruptcy and you can't do anything anymore. And that is something that you have to keep in mind. So it's not like, yeah, we are going to reduce the quality a little bit and it should be fine, but it's rather that you should be concerned if you sort of hit the wall. So some debt is fine. Too much debt will lead to a standstill. And then the question is, what do we do now? Do we do a rewrite? And I don't really know. That's one of those hard to solve problems where, yeah, well, you would probably need to talk to a consultant and figure out a way, because there is no one single easy way to come out of that problem. Technical debt and standstill. As I said, too much technical debt leads to a bankruptcy. So how much is too much? Well, it's invisible. So that is the reason why there is a dangerous game. And therefore, the question is whether the metaphor even communicates that. It seems to imply that you can accumulate more and more technical debt, but there is that certain threshold where there is no way out of it anymore. So Stefan just asked, should technical debt be recorded, noted down, so it is clear technical debt happened? That's one way of dealing with it. And it's actually a feedback that I got from this talk at one point. It seems to be the case that a lot of people work quite differently with technical debt. And if you have a more or less technical debt-free system, then dealing with technical debt in a way that you say, okay, we're going to do a compromise here. We take a note and we fix it later on, might be a good idea. The problem, I guess, is, and that's sort of the perspective that I have in this talk. Usually the systems that I see have lots of technical debt, and that is not an approach that I would take then, because then the question is rather, okay, what are we going to fix first? I think that's the point. So because the idea about talking about the quality of code in terms of technical debt is, I think, not such a brilliant idea, the question becomes, so what's a different way to reason about quality? And there is one way, I think, that you can reason about quality, and those are quality investments. So the way that I think about that is investment should have a payoff. So, you know, I'm taking $1 million or euros, and I expect to get something in return. So if I do it on if I put it on some account, then I get an interest rate. If I invest it in stocks, then I get, well, the stocks will increase in value and these kinds of things. So there should be a payoff, and the same should be true for investments in quality in my system. There should be a payoff from fixing technical debt. So you should only fix it in places where it actually matters, so where changes will happen. And this metaphor, quality investments, is also a financial metaphor. And it is something that people should be, managers should be used to think in those terms, right? It should be something that they should be familiar with. And it's actually more than a metaphor, because you can actually, it is truly money that you're taking. So what you're basically saying is, okay, here is some development effort that directly translates to money, because we are all, well, earning money by developing software. And now we expect that money to have some payoff. So to increase productivity later on, or whatever it is. The quality investments are potentially unlimited. So you can just spend as much money as you like on increasing quality. And therefore, there is no optimum. There is no such thing as that amount of money that leads you to the best payoff. It heavily depends on the situation that you're in. And the payoff is actually what makes this metaphor interesting. So your investment should have a payoff. So for example, higher productivity. So therefore, you shouldn't invest in code that doesn't matter. And you should not make any investments that are too large to pay off. Of course, this is not an exact science. So it's not about doing a precise estimate that says, okay, this is how much we will invest these number of days to increase the quality. And then we get that number of days in increased productivity. But it's rather about ballpark numbers. And the reason why I actually like this approach a lot is because it helps you to justify changes. So this is a translation to something that a manager understands. So if we invest these number of days, later on, it will be easier to develop software, so we save effort afterwards, and you can directly translate that to money. So you can directly translate it to terms that managers care about and that they know about. And it also helps you to evaluate ideas. If you can make the point that increasing the quality in this part of the system will have a benefit in terms of productivity later on, then probably there is no reason to increase quality there. So it's not just about explaining it to someone else, it's also sort of justifying it to yourself and making the point. That is also why I think this metaphor is a good idea. So let's talk about some applications. And this is actually something that I do in quite a few consulting engagements these days. So there are different domains. So there are domains that are more or less important in terms of business differentiation. There are more or less complex domains. And usually this is just a DDD term. There are core domains, and core domains are rather, well, complex, but they differentiate us in the business. So this is where the algorithms are in that are really, really important to our business. Then there are supporting subdomains where we basically, well, need to build it ourselves, but it's not really something that really differentiates us. So in an e-commerce system, the core domain might be the catalog because it's easy to browse through our catalog. And then there might be, and that is what differentiates us from others. And then there might be supporting subdomains to get the data, for example, these kinds of things. So those are the ones that I still have to develop myself, that are still somewhat complex, but they don't really differentiate us so much by themselves. And then there are generic subdomains, something like bookkeeping, for example. It's still very important, because if you don't get your bookkeeping right, then you will have problems. But it is also something that doesn't differentiate us. At least me, I don't buy at any company just because they have the better bookkeeping system. So maybe that's something that you rather want to buy. So my point is that if you think about the quality in terms of these, well, domains, then you can justify them in terms of the benefits that you want to have. So for the supporting subdomains, you want to save costs. For the core domains, you probably want to be able to develop faster, to get new features out faster. So for a core domain, you can basically ask the question, okay, how many more stories can we implement? What would the business value be then? And that business value can be helped to justify stories, so to justify an investment. So in one case, the company that I was consulting, they actually estimated the business value of their stories to justify them, to say, okay, this has to be implemented. And therefore, they could come up with a business value of the stories that they implement. And now if they assume that a system with higher quality would allow them to implement more stories, that directly translates to more business value. So we are implementing 10 million euros in business value each year in our system. If we increase that speed by 10%, then we end up with 1 million extra each year. So that is, if we want to invest 1 million, that's actually something that is justifiable. And we would need to make that. We could try to make that case. And that's actually what this slide says. So let's assume that we make 10 million in business value in stories every year. So let's assume that we gain 5% due to the investment that we're facing. So we could spend 500,000 on those improvements. And that is something that you can easily put on the slide and explain to management. And as I said, this is something that at least helped at that specific client to justify what we were aiming for. For supporting subdomain, well, we could try to argue that we will save on maintenance. So it's rather that you say, okay, right now there are 10 developers who are working on that. If we increase the quality, maybe we can get one developer and put that person on a different thing. Because I'm not sure whether we gain business value from those supporting subdomains. Maybe by better support from the core domains, maybe the investment is not justifiable then, because, as I said, that calculation that I made before, it's not that easy to do that on generic subdomains. So let's talk about some types of investment. First of all, there's refactoring. And refactoring is actually, by definition, restructuring the code without changing its functionality. So things like extract method, rename method, and so on and so on. That's what Martin Fowler's book about refactoring talks about. And that is not one large change. It's an ongoing activity. So ideally, you should refactor the code, then you test the code, then you implement something, then you test the code again, then you refactor again and test again. So, and you go through that cycle multiple times an hour. So it takes minutes to go through this. And it's something that usually developers do and decide about. And therefore, I would argue it's probably, well, it's like this. It's an investment that is sort of ongoing. So a low rate of investment, sort of ongoing, and it helps to keep the productivity stable or maybe increase it even. You can introduce that by things like code retreats, where actually people practice that by pair programming or mock programming, where multiple people work together and, well, execute that cycle. And it's something that is done and decided by developers. So it's therefore something that they can easily do or not do. However, I'm not sure. I mean, I have to admit that I have sort of mixed feelings about that, because refactoring and testing are best practices. And I'm not sure whether I want to explain that to non-technical people. So, if someone comes and fixes the brakes on my bike, I'm not going to argue about them how to properly fix the brakes on my bike, because I trust them. And I think the same level of trust should be there between managers and developers. Developers are the experts on developing code. And if they say this is the way to do it, I should probably trust them as much as I trust that engineer or mechanic who fixes the brakes on my bike. And therefore, I'm not sure whether I want to justify it to non-technical people at all, because, well, business people also don't have to justify business decisions to me. So it's sort of two roads that we have. However, if you pay close attention, actually Ward Cunningham, and he is well known, he is an expert, he also had to explain the value of refactoring to managers. That's the whole reason why we have that term of technical debt in the first place. Also, refactoring is probably not done if the stress level is high. So others, in a way, can influence it. So if a manager decides to put up that pressure, then probably best practices like refactoring just won't happen. And also refactorings are things that can lead to bigger changes. So you can refactor towards a bigger goal. So every time you change a part of the system, you work closer to that goal. And with larger changes, maybe you want to have a different approach. What I'm trying to say here is, in theory, you should be able to change the architecture of your system by just doing refactoring after refactoring after refactoring stepwise, and to sort of keep that at the back of your head every time you do some implementation, you refactor towards that goal of that new architecture. I'm just not sure whether that actually works. And therefore, I'm going to propose a different approach in a second. Thomas just said that Robert C. Martin said you should not get approval for refactoring from management for testing and refactoring. I sort of agree. What I'm trying to say there here is that even Ward Cunningham had to do so. So what do you do if a manager says, okay, you must not test, you must not refactor? And that could happen. And of course, that's a less than ideal situation, but you still have to deal with it. And, you know, quitting your job and going somewhere else might not cut it. Okay, so back to the point here. So refactoring is something that could help you to reach a larger goal. However, there are other ways. So you can have a rewrite or a re-architect. So you would change the architecture. So maybe you want to go for domain-driven design. That is something that a lot of my customers are looking at. And that's oftentimes what starts a consulting gig with me, at least. And the benefits are sort of obvious. So it's easy to say, to figure out that a clean domain-driven design approach would lead to many benefits because the business would be much better supported. And therefore, it's not hard to figure out the goal. Well, here is the new great architecture that we want to aim that for. But it's much harder to understand how we would get there. And sometimes it's even completely unclear. And one thing that I went through with one client at least was to just estimate how much effort it would cost them to redo the architecture. Then you could estimate the productivity increase that you get. And, you know, these estimates should be common. It is something that we sort of do every day. So I don't see why this shouldn't work. It's something that we should be used to. So in that case, we would make a huge investment and then we gain a productivity improvement after we did that investment. And this diagram sort of says what the problem is. The problem is that we have a huge investment that can take several years even. So one team that I consulted with estimated that it'll take them 7 years to come up with to implement the new architecture. So that means that the team will keep the current productivity for quite some time. And if you just focus on re-architecturing the system, then they won't produce features. And, you know, if you don't produce features for 7 years, that's probably not going to be something that is enjoyable by anyone. And there's also a huge risk. So what I'm trying to say is such a rewrite is probably just a theoretical option. And I myself wouldn't give anyone 7 years of time to rebuild a system without seeing any benefits in between. That's just probably not going to happen. So therefore, I would argue that we have to have incremental investments, several bigger investments, several larger steps towards a new architecture, but each of them has to have some kind of payoff. So you would modernize a part of your system that is, for example, changed frequently, that is changed anyways, these kinds of things. So you would basically say, okay, tell me about what the next few business changes are. How are we going to support them by implementing parts of the system in a new way, by, well, making them easier to change. And then you have these incremental investments. So you would make an investment to improve the quality of one part of your system. And then the productivity is better for implementing the new stuff in that part of the system. Then you take the next part and so on and so on. Still, these are big investments, but you get payoff rather in the short term. And you can also stop the improvements anytime. So there is a smaller risk. And figuring out what to change is actually very hard. So figuring out that an ideal domain-driven design architecture would be much better, that's easy. And you can easily come up with a discussion about that. But figuring out what the first part should be that should be improved, that is actually hard. Now, the question is, who decides about investments? And that basically sort of comes back to the question that Thomas had. I would argue that good craftsmanship like unit test refactoring is something that developers will probably decide about. And there's probably another answer to Thomas' question on this slide, because I'm not sure whether managers, like true managers that don't really look at code, how would they even notice that you do or don't do refactorings, or that you do or don't do unit tests? That's actually the whole point about technical debt, that this is something that you cannot really see from the outside. So one strategy to deal with that is to just do it, because it won't be noticed anyways. You can have a team budget where you would set aside some time to work on quality. So in every sprint, it's 14 days, we spend 2 days or whatever on improving quality. This is useful because management might not care about sustainable pace. I think one of the core problems is that you tend to be relentless. You want to get results as quickly as possible. And if you do that in a software system, then you end up with technical debt. That's why we had this discussion about relentless technical debt. This budget is something that helps to solve that problem, because it assures that at least something happens. We will spend 2 days every sprint to work on quality, so it will be improved. The problem that I have with that is that there are business goals. As I said, there are specific parts of the system that we are going to change in the not too distant future. So ideally, we want to increase the quality in exactly those parts of the system. So therefore, if we had a better relation to management and to a better idea about what's going on about the backlog, then we could prioritize quality on those parts that actually matter. So this team budget, to me, seems like a workaround where the teams are allowed to do something, but you might end up with them spending effort in the wrong places. So maybe it's a management decision, or ideally, I would argue it should be a management decision, because they can change priorities, business goals. As I said, maybe if I get that really ugly system that nobody can change anymore after a year, maybe that's what I want, because then I can go to investors and say, okay, we have some users, so please give me a lot of money so that I can rewrite the system. And that's this ship now versus investment in sustainable pace. And I think the problem here is that you might have a bias towards shipping now, and then there is a problem, because the management will keep you doing stuff relentlessly, and you would end up with technical debt. But on the other hand, a management decision is probably the only thing that helps you to say, okay, we are going to invest, I don't know, a lot of effort to aim for this new architecture. So usually, I don't think that it is possible to redo the system as a domain-driven design system without management buy-in. That's the point that I'm trying to make. So you can easily do refactoring and testing without a manager ever noticing, but doing a larger restructuring, I don't think you can do that without buy-in from management. So in conclusion, while technical debt is a metaphor for internal quality, debt can lead to a standstill, and I would argue that you should avoid recklessness because that leads to technical debt. I think quality investments are an alternative and probably better way to think about how you want to deal with quality, and because they support decision processes where you end up with fixing problems in a specific part of the system. And the things that you can do are refactorings, which I believe more or less every developer can do. Rewrite, re-architect, which is something that I wouldn't really do because it's sort of big bang and a huge investment, and it's hard to figure out the payoff. So incremental investments are the other thing that I would look at. I wrote an article about quality investments with my with a friend of mine, Felix Müller, on InfoQ, so you can read that up. I also did a podcast with Sven Johan, also quite some time ago. I should probably mention that I sort of summed up all the stuff that I did in the years, so over the years. So I actually was also part of a program committee for a conference on technical debt, and as you can see, I'm dealing with that subject for quite some time now. I also wrote an article about managing technical debt with Sven Johan. there are a few German links. So I did a podcast at Heise. I did a blog article at Heise. I did the same article about quality investment with Felix Müller, as I said. And there is also another article that I wrote. And sort of the original reason why I even started doing this talk is I do a mostly German stream every Friday. And I did an episode about technical debt. And I did that because I invited Andre, who talked about how technical debt is very important as a CTO. And I noticed that I actually had to say something about that myself. So I did that one episode where I would talk about it myself. And this is how I even got the idea to do a complete talk about it, because it's still something that is valuable. Quality scenarios and refactoring is also something that I talked about in that stream, and you're more than welcome to join the stream. Yeah, so concerning the links, so if you found this interesting, here's an email address. It's jcon2020@evolve.com, and you get a link to the Dropbox with the slides and a few free publications and sample chapters from the other publications. This is powered by Amazon Lambda, and it's actually a small microservice. So your email address will be locked for 14 days. And if you misspelled your email address, it'll go to my inbox and I'll fix it manually and send it out manually to you. So I think that's the easiest way to get all those links on those slides, and then you can just copy paste it. Okay, thanks a lot for listening. I still have a few minutes left, probably. Well, actually, if there is a question. Might potential future security issues justify the need to reduce technical debt? That's actually a good question. And so thanks for asking that. And it's interesting because it basically touches on this relation between internal and external quality. A security issue is an external quality problem, right? It's something that I can notice as a user or a hacker or whatever. And the internal quality, this is what we are talking about, code quality. In theory, those should be two separate things, but at the end of the day, if you have bad code quality, probably some problems will sneak in, such as problems concerning security. So therefore, the sort of theoretical answer would be no, because we are just talking about internal quality here, and security is something different. However, in real life, there will be a relation. So maybe that is something that you can use as an additional discussion when you talk about the payoff, right? So we expect to have less security problems. So therefore, we get more we get more benefits from increasing quality. If you can't get management buy-in, what is your take on submarine projects? Well, this is sort of what I was trying to say. I think in the ideal world, management should make conscious decisions together with developers on quality. And if you don't do that, then there will be a problem, because at the end of the day, we want to reach business goals, and investing in quality in parts where it doesn't really matter, doesn't support business goals, just decreasing quality by being reckless is also something that doesn't really help concerning business goals. And every other thing, like, for example, the budget that I was talking about, where you set aside a budget, or where, this seems to be similar, right? So someone just starts working on the quality of a system. It's probably better than nothing, but it still says that there is a problem, right? And there is a social problem about how management and developers don't have a common understanding about what they want to do concerning quality. And I would still try to fix that, because, as I said, at the end of the day, I don't want to build a system that is pleasing and that is great to look at. I just want to solve business problems, and therefore business and development needs to collaborate. And if they don't, then there are ways to sort of work around that, but it's not fixing the problem. Okay, then I think that's it. So thanks a lot for listening. Thanks a lot for the questions. And I'm actually going to do another talk tomorrow.